Swayam Prabha. Digital India. Educated India.
Hello and welcome to the first lecture in the Affective Computing course. Friends, I am Abhinav Dhal from the Indian Institute of Technology, Ropar, and today we will be discussing about the fundamentals of affective computing. So, the agenda for today is as follows. We will first discuss about the topics which are going to be covered in this course. We will talk about some resources which you can refer to, and then we will introduce what is affective computing and dwell a bit deeper into one of the major components of affective computing, which is referred to as affect sensing. From affect sensing, then we will come on to the various components through which we can understand the affect, and that is through the different modalities which is based on different sensors. So, we will start with the fundamentals, then we will move on to emotional theory and emotional design. So, some of these topics will be covered by myself and others will be covered by my colleague Dr. Janindra Shukla. So, Dr. Shukla will discuss about how the different emotions are represented computationally, what is the theory of emotions, and what are the concepts of emotion enabled design. Then the discussion will move on to how do we elicit emotions in a person, and once we have elicited emotions, what are the different research and development tools which are available in the community, which you as a practitioner of affective computing can use in your respective projects. From this, we will dwell into how we can understand emotions from facial expressions. This would be primarily focusing on the camera based image and video based analysis of affect. From this, we move on to the other modality, which is voice. You can hear me right now, you can tell what is the emotion in my speech, right? You can hear that in my voice. So, we will discuss the different methodologies for voice based emotion recognition. From this, we move on to text, and then we will move on to physiological signals, your heart rate sensor, the EEG and so forth. Later on, friends, we will combine this into multimodal emotion recognition. That is, we have data coming in from, let us say, voice and text, or there is data coming in from camera and physiological sensor. Now, once we have discussed the sensing part, we will also come to how emotion is reflected by a virtual agent, how can be communicated by a machine, and if you have a robo, when you are talking about human robo interaction, how do the robo, after sensing the emotional state of the user, react to it. Then there would be discussions on the challenges and opportunities in this area. So, this is a very new area. It was introduced only 3 decades ago. So, if you compare it with other disciplines in computer science and signal processing, this is fairly young, which means that there are large number of opportunities and also there are a fair number of challenges which are involved. Then we will move on to a case study of a real world deployment of an affective computing system, and then last but by no means the least, the very important aspect of the ethical, legal and social implications of affective computing. Now, if we want to move these affective computing systems from, let us say, labs and to real world settings, what are those aspects which we need to be aware of from the perspective of ethics, legal and so forth. Now, this course is fairly self-sustained. the material which we will be sharing with you through our lectures should be giving you a healthy amount of information about effective computing. And with this also, I would like to mention to you some of the textbooks for those of you who would like to, let's say, go deeper into the concepts. Now, from Professor Rosalind Picard is the first book in this area, which is aptly named Affective Computing. Then a recent book called the Oxford Handbook of Effective Computing that was also released. It's a very rich set of resources for concepts in effective computing. And then a very new book by Liement and others, which is called Applied Effective Computing. That is also a very good resource. Now, since effective computing is a very growing area, rapidly growing area, much of the newer work which is being done in universities and in industrial labs, that is first communicated to, disseminated in journals and conferences. So, the IEEE transactions on effective computing, that is the standard venue where the high quality effective computing work that is shared by researchers. The community also has a conference called Effective Computing and Intelligent Interaction, and this conference is also a go-to resource for the very recent works. Now, since effective computing is fusion of concepts from computer science, signal processing, machine learning, and concepts in how emotions are represented in psychology and social sciences literature. So, therefore, this is an ensemble, a fusion of different areas. Now, what that means is there are some other venues, some other resources as well, wherein in part effective computing work is presented. So, for example, there is a conference called ACM Multimedia, where you will find recent effective computing works published as well. And then there is a conference on multimodal interaction. So, there are different sensors, multimodal, and then there is interaction part. Also, we see affect related work in computer vision conferences such as the Computer Vision and Pattern Recognition and the International Conference on Computer Vision. Now, these resources are fairly advanced resources. So, I would suggest that if anyone is interested in exploring the recent works, you could start that towards the later part of the course. It's not exactly within the scope of this course, because our course is essentially an introduction to effective computing, but these are extremely high quality resources for going into advanced effective computing. Now, throughout the discussion in this course, Dr. Janendra Shukla and I would assume that you would have learned, maybe credited concepts in machine learning and would have been introduced to at least one type of signal processing. It could be through camera, image processing or computer vision, or it could be speech processing or NLP, natural language processing. Because as I've already mentioned to you, effective computing is you get some data from a type of sensor, you do signal processing on it, you do machine learning, and then there is the human computer interaction part. So, now friends, let's formally introduce effective computing. So, the field of effective computing, it encompasses both the creation of and interaction with machine systems which sense, recognize, respond to and influence emotions. Now, this term affective computing was first coined by Professor Rosalind Picard at the MIT Media Labs, and it is essentially about two components. First, We want the machine to understand the emotional state of the user, and once machine has this information, how should the machine react to it? In other words, how should the information be now presented through the interface or through voice or images to the user, which is an appropriate response to the user based on the user's emotional state. So, you recognize the state and you react accordingly. Now, if you look at the affective computing systems, right? So, there are a large number of components to it. So, on one side is, let's say, a machine, could be your mobile device, which has some AI capability in the camera module or in the speech modules, and then on the other hand are users. So, your affective computing system can have different components. It can recognize emotions, it can have behavior analytics, there would be a dialogue system for interacting with the user, there would be an interaction system. Now, for example, interaction system is simply, let's say, you are browsing through an app on your mobile phone and are using the touch sensor. So, that is the way, one of the ways for the user to give feedback. So, the affective computing system will have observation of a user's behavior and mental state. It will understand it, compute it, and then it would synthesize and adapt to the user, and that would be actions to influence a user's behavior and mental state. An example is, let's say a operator is using a complex machinery. The machine senses that the user is fatigued. So, this is this part, and it would then, let's say, share a recommendation to the operator that you can now please have a break, maybe you can relax a bit, right. So, that is one of the appropriate response from the machine to the user. Now, if you notice from this particular part, we have signal processing machine learning, again signal processing machine learning, the HCI part, the AI part, and this is the recent works in synthesis. For example, using deep learning, generating images, voices, videos, and so forth. We already see that in the artificial intelligence domain, there are several well established directions, and in these affective computing finds high relevance. So, to start with, in speech, there are two parts to speech from a computer's perspective. One is understanding the speech of the user, which could mean, for example, automatic speaker recognition, automatic speech recognition, wherein the system tries to understand the spoken words, what is being spoken. Now, in this pursuit of what is spoken by the user, what can be computed is that when the user spoke, what were the emotion which you could sense while the user was speaking. So, that will give you the emotional state. Once you know the emotional state, from the speech perspective, you can generate speech as well, right. So, it could be, let's say, a text to speech system which is generating the speech based on what was sensed from the user. Let's say the user sounded sad. So, how about if the text to speech system generates a happy or at least a neutral toned voice, right? So, that would perhaps maybe help the user. Then we have the face analysis domain. In the case of face analysis, there are a large number of directions. An example is, we are already doing things such as face detection, face re-identification, verification in artificial intelligence. So, the subdomain of computer vision and machine learning. And within this, we can use the same pipelines adapted to understand the facial expressions. A person smiles, if you notice me right now, or the person is sad, right? So, we find a large number of applications in the face analysis domain. Now, that is again detection, right? But you can synthesize as well. Let us say a user is interacting with a virtual agent. The virtual agent senses that the user, let us say, is happy, and the facial expressions of the virtual agent along with the tone are also cheerful. Then with lip reading as well, lip reading, friends, is, let us say we have an input video and we want to analyze the lip movement so that we can learn a system which can predict what is it that the user is speaking. Now, in this pursuit, lip movement also tells us about the facial structure corresponding to a particular facial expression. You smile, let us say, when you are speaking, or you are showing a surprised expression as you are speaking. Then in monitoring as well, let us say system monitoring, or even a scenario, for example, there is a product, you are showing it to a bunch of users and you are analyzing the emotional state, the behavior which is elicited in them in response to the product which is being shown. In the later part of this week's lecture, I will give you an example of this, how affective computing is useful. Then in gameplay as well. So, along with the keyboard, mouse, we can use the facial expressions, the head pose information of where the user is looking, how is the user reacting to the gameplay. And for much serious applications, perhaps let us say for training someone with facial expression issues, one could have a game where you are supposed to show facial expressions and you reach only to the next round if the facial expression is as shown to the user on the screen. Then from social skills analysis in AI, right? Now, let us say you have a group of people, there is a conversation happening. How do we use things such as back channeling, understanding of cohesion, unity in a group? So, there as well we can use affective computing, essentially the perceived emotion of a group, and we can then add it to the social skills understanding. Now, a thing to notice here is, throughout this course, we will be using the term emotion and perceived emotion interchangeably. As you can see, this is based on the perception. When you meet someone, what do you think is their emotional state? Well, that is based on what they are speaking, what you see on their face, on their body gestures. That could be in some circumstances highly correlated, but in others it could be having a low correlation, right? So, we will use perceived emotion and emotion interchangeably. Now, coming to the aspect of the first component of affective computing, which is recognition, right? We refer to it as affect sensing. You want to sense the affect of the user. What is the affective state? So, formally, affect sensing refers to a system that can recognize emotion by receiving some data through signals and pattern. So, this is the formal definition from Professor Rosalind Picard. Now, for achieving this task, a computer would need certain hardware and certain software. The hardware would be essentially the sensors which are going to capture the information, and also, as we are going to do pattern recognition in this case, we want to identify certain patterns from the data which we have captured from the sensors. We would need a fast, high quality compute. Perhaps in some cases, let us say a graphic processing unit, if it is a machine learning, deep learning kind of system which is being built. From the software perspective, platform for interfacing with the hardware sensors and software libraries which can process the data feed coming in from the sensors and also then learn pattern recognition machine learning model. Now, if you look at the hardware, we can sense from this perspective the affective computing systems on the basis of the modalities which are used to get the data. Okay. So, affect sensing can be identified based on what type of data are you analyzing, what is the modality of the data, which will then translate into which is the sensor which you are using to fetch that data about the user. Now, a very simple thing for that would be, let us say you are sitting in front of your computer and you are interacting with a software using your mouse and keyboard. So, now the modality is the data input which is coming from the mouse and keyboard, right. Now, let us look at the primary modalities for affect sensing in affective computing systems. So, friends, the first is using a camera sensor, we analyze the facial activity. Now, the facial expressions which come on your face are a window to the emotional state. So, cameras are very commonly used as one of the popular modality for affect sensing. Now, what you are saying essentially here is, here let us say you have a camera and on the other side you have a subject, you capture the image and you would like to understand that, for example, for the subject in this image, the person is happy, right. So, capturing is done and after pattern recognition, this is the affect which has been sensed that this person in the image looks happy. Now, in the past few decades, we have observed that the cameras are getting better in terms of the image capture quality, resolution and so forth. And in parallel, due to the progress in hardware, the cost of cameras is also going down. So typically now you will see that your webcams in your laptops and the cameras which you have in your mobile phone are capable of capturing high quality clear images, right. So it means, if you are creating an effective computing system, you can easily find a camera. And if you can find a camera, given that they are very well already fixed and have an easy to use interface with the machine, for example, in your mobile phone or on your laptop, you can fetch data from the camera. The issue which comes, friends, is that yes, you can capture an image of a person from the camera on your laptop or mobile phone, but why were we doing this? Well, the aim was affect sensing. We wanted to understand the emotional state of the user. But in this pursuit, we are capturing the face of the person, and this face also gives us things such as identity, age, gender, which may or may not be required by your affect sensing system. But it can tell very important information, private information about the user. So that is where some privacy issues come into when we are using a camera. One solution is, well, most of the cameras which we see around us in our day-to-day lives, they are RGB color-based cameras, right? You get a color image, as you can see on this side of the right side of the visualization on the slide. But then there are other cameras as well, for example, thermal cameras. So here you see on the left side, friends, the feed of the same person's face from a thermal camera, and what is happening is, this is telling you the temperature distribution. Now, how does it tells us about the affect? An example is, let's say a person is feeling fear, so that is the emotion, and as they are feeling fear, they are maybe rapidly breathing. So when someone rapidly breathes through the nostril, due to the movement and action of the muscles, the region around the nostril, it starts warming up. You can actually sense the temperature difference in that part of the face. So one can then use this difference which you observe in the feed coming from a thermal camera and predict the emotion. The advantage, of course, is that it's easier to preserve the identity as compared to in the case of color camera. The disadvantage is that thermal cameras are expensive and relatively have lower resolution as compared to color cameras. Now, this was for when we are looking at a face, right? Let me show you an example, friends. So let's say there is a camera. So this is a camera which I have created. Here is a person, and you got the image or the videos. This is just showing you some frames. You do feature analysis, some statistics. Well, we will be studying this in detail in the forthcoming lectures. And then you do some machine learning, okay, to predict if the emotional class. So this is an example which I am going to play for you guys. So this is me, and what we have here is the face being detected using a computer vision library. These dots are telling about the facial points, and the corresponding location of the facial parts. So, using the facial point information, you can tell the structure of the face, which can tell, let us say, if the subject is feeling happy or not, right. We are taking a very trivial example here. So, this is how it should look like. So, you can see in this case that, let me play the video, let us go back, play the video. Okay. So, you see this is happy expression, and also that there is a particular direction. So, this is, friends, this is called eye gaze. Now, gaze also gives extremely important information about the affect. So, it tells you where is a person looking. Now, imagine a scenario, someone is watching a horror movie and they are anticipating a horror scene coming up. Maybe in that anticipation, the person may not directly look at the screen and may look on their sides. That is a very important cue. So, you knew that the task was that the person is watching a movie, but the person is not watching at the movie, and you know their gaze is moving left or right. Could be that the person is not really immersed in it, not engaged, or it is simply an indication that the user, since is watching a horror movie, is anticipating a very high horror quotient scene, right. So, you can use the gaze. Now, again, your eye gaze is captured through the camera, and we have seen in various amount of works that this camera modality based eye gaze, that gives us extremely important cues about, let us say, if a person is making eye contact or not during a conversation. Making of eye contact can be used to assess large number of attributes, confidence, are you, let us say, speaking entirely truth or not. So, the camera enables gaze along with face analysis. Now, through the camera modality, we can also have the pose of the person. Okay. Now, what does that mean? That means, if you notice my video right now, and let me try to act. Okay. What? Did you see a lion at the zoo? Now, what has happened here, guys? In this small act, I had a facial expression, surprise, and even the hand gestures, right? They moved up. What did you see? Wow. Typically, you will observe this when, let us say, people are watching a game, right? A football or a cricket game. You can tell them from the gestures that what is the affect. So, through the camera, we can easily tell the pose and the gesture. And this pose and gesture can give us important information about the emotional state. You can tell very easily from the image illustration here. So, here you have two people. You can see that person 1 is keeping his hand on the shoulder of person 2. Person 2's left hand is on his head, and it seems as if they are, in a situation where person 1 is consoling person 2. and person 2 visibly looks upset, right? You can tell that from the gesture. So, this gives us very important information about the affect, right, the affective state of the user. Now, let us change gears and move from the camera modality. What we have here is the microphone voice based affect sensing. So, in this case, you will have a microphone, you will be capturing what the user is speaking and then analyzing this information to predict the affect. Now, in certain scenarios, along with prediction of the emotional state of the user through his or her speech, one can also make sense of the overall scene. So, through the microphone, you will be capturing, let us say, the background noise. Maybe there is some music playing in the background, which can tell your affect sensing system that the user, let us say, is in a place where music is playing. So, maybe the user is not in his or her office. Now, if the user is not in her office, then maybe the chances are high that the user is in a casual setting. Now, based on the perceived emotion of this music which is playing in the background, I can have auxiliary information, extra information about where the user is, and that can tell me a more accurate understanding of the emotional state of the user. So, in this case, you would capture the data about the user from the microphone. Let us say this is the waveform which is captured. We will extract some information from this waveform, some features, some statistics, and then there would be a machine learning model, okay? Similar to how we do for faces. You have a camera, you capture the face, you analyze some statistics around the face, and then you have a machine learning model which is going to predict the emotional state. So, friends, now we have seen camera based modality and microphone based modality. So, these are the two types of data feeds which, let us say, if you were interacting with someone, you would be analyzing them in real time. Two people are talking, one is able to understand the emotional state based on the facial expressions, pose, that is what the person sees, and what the person hears, right, from the voice, tone and so forth. Now, another modality in affect sensing which is very prevalent is coming from text. Now, we have documents, email conversations, messages which we send over platforms, and then social media posts. So, all of this gives us huge amount of data about a user, about a scene, but in the form of text. Now, this text could, let us say, be an article which someone is writing, or it could be a chat which is happening between a user and an agent. This could be a virtual agent. So, this is like a conversational AI based use case. So, in this case, the human is communicating with the machine through text, chatting, and the response to the human is also in the form of chat, text. So, the user now would be sending a message, and we can try to understand the affect, the tone from that text, right. So, that is coming to the natural language processing, right. We would like to understand the affective state based on what is written by the user. Now, of course, this would span across different languages, and what it means is, in different languages, users will convey the same emotion but in different forms, different ways of phrasing, different words. Therefore, for this human machine interaction using text, we will have different models through which we can analyze words, sentences and documents. And we can also analyze human-human interaction. So, let us say there is a job interview scenario, there is an interviewer, there is an interviewee. Later on, we take the speech data, transcribe the speech data into text, and now what we will have is the conversation, let us say, between the interviewer and the interviewee in the form of text. Now, we can analyze this conversation between the interviewer and interviewee and extract statistics around that text, which can help us in predicting things such as how was the affect state of the interviewer and interviewee varying as the conversation proceeded. So, that would mean an example like this. Here you have document. You could analyze the words, the sentences, paragraphs, the links between sentences, how the neighborhood words are for, let us say, a particular word. Extract these statistics about the document, have your PRML, the pattern recognition machine learning model, and that can tell you, let us say, the emotion. Now, there are so many applications of text based sensing. You see, I told you about this human machine, human interaction, chat, email and so forth. But it is also about, let us say someone was writing a poem, someone had a document which is coming from a book hundreds of years old, we are digitizing it. Now we want to understand what was the emotion which is conveyed in the document or the poem by the writer. So, we can actually have that objectively measured, right, and that is the affective sensing part coming through text. Now, in the case of affect sensing through text, you would have noticed by now, friends, that the identity information, you can hide that in this case. So, you can actually do parsing of the text, you can hide private data and then try to make the affect related sense of the data. Now, if you compare that with a camera, a color based camera or a speech based pattern, because in the case of speech as well, one can analyze the speech and extract things such as the probable age range, gender and even identity of the person. So, one could better preserve privacy in the case of text as compared to speech and camera based facial analysis or body pose. Now, moving in this direction forward, the other type of modality which is commonly used in many affective computing applications for sensing the affect is through physiological signals. You could think of it this way: when you hear someone and you see someone expressing a topic, hearing and watching, viewing is based on the facial expression and voice which are outside of the person, right. you see how their facial expression is, you hear what they are saying. Now, how are the different parameters, attributes of the person inside, implicit information? Now, what could that implicit information can be? A very simple example is heart rate. So, if a person's heart rate is relaxed with reference to their normal, then that's a very strong information for a classifier to judge if a person is, let's say, neutral, relaxed, or is aggravated, right? Now, a commonly used physiological signal sensor along with heart rate sensor is your electrothermal activity or electrodermal activity sensor called EDA. What it does is, so it will sense the change in conductivity in the skin due to the increase or decrease of the activity in the sweat glands which we have on our skin. You know, the very small microscope observable sweat glands. Now, what that means is, it has been established that as your affective state changes, you could feel more stressed or not stressed, angry, fear, or happy. We see changes happening on the skin as well. Okay. Now, you could measure that. For example, here you see one of the sensors from Biopack where you are actually measuring this. Okay. So, there are two electrodes here and you are measuring the change in EDA activity, okay, electrodermal activity. Now, similar to how we did for text, you have this modality, physiological sensor EDA, continuous, let's say, data is coming in and we are extracting statistics again. About the EDA data, there is a ML model and then you predict. Now, in the case of your EDA data, what is the positive side? It is privacy preserving. We are not recording any information about the identity of the subject. What is the disadvantage? The user has to wear it. So, it is intrusive, right? This is not natural setting. We do not wear these sensors. Of course, now if you see, friends, the smartwatches which are getting quite ubiquitous, very common, they will have these sensors. So, as the form factor, the user experience is such that these sensors are gelling well on the human body in their human user's natural environment, they will not notice. However, for these kind of sensors, high quality, high fidelity sensors, the user notices that there is something on the finger or on the skin. So, they are intrusive. Okay. So, in a few cases, this may actually add to its own bias to the data, that the user is aware of something, but then that is also possible in the case of a camera, right? Right now, I am looking into a camera, and if I was asked to smile or show fear expression, I may become camera cautious, right? So, that may not be the very natural expression which I otherwise would show in the world around me if I was not aware that there is a camera which is noticing me. Same goes for this physiological sensor. If it is on my fingers, I may be aware that if I move too much my hand, I may actually maybe break away or I'll add some damage or noise to the data. However, strong advantage is that you are preserving the privacy. Typically, we will use these kind of sensors as an ensemble. They will have multiple sensors in your physiological signal based affect sensing. So, another very commonly used sensor along with the EDA is your EEG Okay. So, that is your electroencephalography EEG sensor. What is your EEG sensor, friends? You can see here, this is a EEG cap. Okay. What you have here is these electrodes, and what these electrodes are doing is they are recording the electrical activity in the brain, in the neurons. So, why are we using this for affect sensing? When you see a stimuli, a video, or you are talking to a person, we are sensing what they are saying, we are observing the world, and that whole perception is happening inside our brain, which triggers different neural pathways, and that is measured by EEG. Now, you can see here, in the case of the EEG, the person has to wear, slowly EEG caps are also getting very user friendly, easy to wear, similar to how we had for EDA, strong positive point. You are actually trying to get data right from the brain. What does that mean? How does it make it different from a camera? Let us say I was a very good actor. Maybe I was feeling very happy prior to I came to an environment where the environment is supposed to make me show in the social settings a bit of a sad reflection, right. So, what I am trying to convey here is what you are feeling and what you show on your face, sometimes that may not have the direct correlation. Okay. So, what you are capturing from the camera or hearing from the microphone in the terms of a voice of a person, that could be more towards the perceived emotion, but not maybe the real emotion of what the person is feeling, right. Classic example is the actors. Some actors will get so much well into the role that they will show different emotions, but are they truly feeling those emotions? There could be a gap here. But when you come to these physiological sensors, for example, through the EEG, there you are measuring the different signals from the electrodes. So, let us say these are different electrodes, right. The user can try to control their thought, but that again, this whole pursuit would be captured. So, it may sound like now that the EEG is the most perfect type of sensing modality for affective computing, but it has its own challenges. Well, one is it is not natural to wear these EEG caps. The user is aware that there is something on their head. Then you have a bunch of electrodes which are connected to these wires. So, if the user moves a bit, then that noise is also added to the signal which is being captured. The placement of the cap, and also that if let us say there is a particular sensor, one of the electrode that is not functioning correctly, you may not actually realize that till you analyze the data. So, the whole process of data capturing has been done, but one may not realize. Okay. The other challenge which comes with EEG is you cannot trivially easily take it outside, right, outside of the laboratory setting. Now, if you compare that with a camera or microphone, you can use the microphone or the camera sensor in a mobile phone, take it anywhere with the user, and you are able to sense the affect. But with EEG, that is a challenge. But what we get is a ground truth data, data which is far more closer to the user. So, what is going to happen, guys, in the pipeline? You have the EEG sensor, you sense this data, again similar to how we have been doing, is extract statistics, features, and then you have your machine learning model and you give the effect. So, there are a large number of these sensors which are available to us to predict the affect. So, in nutshell, we see that we can divide, based on our discussion, the modalities based on camera driven modalities, which give you the perception of sight, the faces, the body pose, gesture, simple things such as the hand tension. Let us say me right now strongly clutching my hands and then rotating. This can give you a very vital cue. If in a real world setting I was doing this, it can tell you a lot of information about how I feel. Then we have, friends, your microphone, which gives you the voice, the background knowledge, and you can use one microphone when you have multiple people, right, 2-3 people who are, let's say, in a closer proxemics, closer to each other in space, and you can have one microphone in between. Now, the challenge with camera would be you may require multiple cameras to focus on different people of a group, right. So, there are these settings based challenges which are going to come. Then, friends, we have your language processing, natural language processing through text data, documents, emails and so forth. So, that is another modality. And then we took examples of these two physiological signals based on EDA, your skin, and based response, and EEG, the brain neuron based response. Typically, we will have combinations, you could have camera plus this, or maybe a text which is being read by a user. So, you have microphone, you have the text. So, we can use these different modalities in tandem together to get complementary information. Now, all of this is dependent on the type of project on which we are working, right. What is the type of data which is available? What is the scenario in which the user will be using the system? So, that will decide, if a camera is possible, is privacy a super concern, and if it is a static position, let us say a person can sit and then you can use a EEG kind of sensor or not. So, with this, friends, we reach to the end of the first part of the fundamentals of affective computing. In the second part, I will be introducing you to some of the applications in different domains of affective computing. Thank you.